Okay, so why don't we get started? Again, this is a Kubernetes half-day seminar. It's going to run from noon Eastern Standard Time till 3 p.m. We'll be running mostly straight through. There may be a 5-minute break in the middle at some point, but other than that, we've got a lot to cover. Okay, so let me tell you what it is we're going to be looking at. Here's our agenda. So these are 5 topic areas that we're going to be looking at. First is cloud managed Kubernetes. Okay. You may have worked with Kubernetes locally on your own machine just to try it out, or in your department in order to set up applications. Okay. We're going to be talking about Kubernetes that's managed by a cloud provider. Okay. So, you have Google Cloud Provider, you've got AWS, you've got Azure, all these different places now have Kubernetes services. So we'll talk about that and how it can be managed there. We're going to be talking about application and package management. So on top of Kubernetes, there is an easier way to bundle up applications and deploy them with simple commands. Now you might say that Kubernetes has fairly simple commands, but you'll see when we talk about an application, we're usually not talking about one thing that needs to be executed. Usually there's several things, and it's good to be able to put them all into one bundle and then just execute the bundle at once. And that's something that we can do with a tool that we'll be looking at called Helm, which is a tool you may be familiar with. It's also used by some of the cloud services. Then we'll take a look at multi-cluster management. Multi-cluster management is all about when your need for Kubernetes grows, you're most likely going to have more than one cluster or many clusters, dozens of clusters, for different reasons, and we'll go over some of those reasons. But if you have to log into each one and manage certain things that would normally be managed across the clusters, like security and things like that, it would be much easier to do that if they could be managed in one interface, right? That you could just connect to the clusters all through the one interface and make certain changes across them all. So we'll be talking about the systems that we can use to do that. So those topics are going to be the majority of what we're talking about today. But then also to round things out, we're going to talk about skill sets in Kubernetes. Okay. Now, some of you have probably been working with it for a while, so you'll be familiar with these and how tasks are divided into different roles when you're working with Kubernetes. So we'll be talking about things like that, but it'll also lay the groundwork for some of the more junior members of the audience here who are thinking about how they want to architect their own profession, or their own career when it comes to Kubernetes, right? And then going along with that is the Kubernetes certifications. We want to take some mystery out of what those are about, which certifications are available, how that works. Okay, so that being said, we're going to get rolling. Now this is where I'm going to open up the other presentation. So this one presentation, I think, would have come, this short one, the PowerPoint, would have come maybe a day or so ago. I'm not sure exactly how they sent them out, but this other one was just finished up this morning. So you may have it now, or they may send a copy of it to you after the presentation. Okay, so let's do this and go to here. Okay, cloud managed Kubernetes. Okay, so we're going to go over these different topics, starting off with use cases for the cloud managed Kubernetes, and then talk about some of the aspects of why you're going to choose to have something managed in the cloud rather than on premises, or maybe you have both. Okay. Then we'll talk about some of the services that you can employ to do that. Okay, so what are the use cases for cloud managed Kubernetes? All right. So these are some of the ones you're probably familiar with. So if you have applications that are dynamic, their workloads change frequently, right? Now, if you're thinking of a standard application like a website, your amount of workload probably goes up to a certain level and stays at that level, doesn't maybe change unless there's some kind of news event, and then people start flocking to your site, and all of a sudden you want, instead of having 5 instances handling traffic, you need to have 10 instances of the application handling traffic. So those dynamic workloads, ones that could change, you want to handle that, and think about how you would handle that in-house. Like if it was on premises, right, and you had one big machine that was handling your website load or application load. What would happen if that load doubled, right? Well, you'd probably hit the limits of the machine, and if you were careful enough and you were quick enough, you might be able to take some virtual machines and throw them into the mix and add a couple pods. But if you weren't, if this happened, at a time of day where you were busy doing something else, then it could easily max out the machine. And things don't work as well when they're working at the edge like that. So it's possible that things could break or not work. So either way, it's going to be a situation that you're probably not interested in having, with the application not performing the way it needs to. Right. So the idea about having this managed in the cloud is that you can have the workload can be handled across different VMs that are put up for your site. But in addition to that, VMs can be spawned in response to the demand, and they can be done automatically, right? So the hardware is already there because they have a pool of hardware that everybody can use, and if somebody else is not using it, you can use it, and this can handle your workload, and even when it's dynamic. Okay. So this same kind of scenario there's a similar reason for using cloud managed Kubernetes in these kind of behind the scenes, in these other bullet points. If you're involved in big data processing, that's the kind of thing that does not, you might not have a constant workload for. You set up something, and then you're going to run a job, and you're going to mine this data, and then it's going to come back with a result. And while you're looking at the result or checking things out, there's downtime that you don't need the machines anymore, right? So you're still paying for the machines if they're on premises, right? These big machines that are handling a large workload there. But it works much better when you can just spin up your process in the cloud, and you can let, say, AWS or Amazon take care of spinning up the machines. Okay. So big data processing is kind of a subset of having intermittent needs for large processing capacities. Okay, so that could be because of big data processing, could be for some other reason. Okay, but it still comes down to the same thing. You need to make the capacity available. Okay, one of the other reasons why you might want to manage something in the cloud when it comes to Kubernetes is that you want to spread out your talent, your IT talent, and if they're busy maintaining physical aspects of our clusters, okay, then they're not available to do other types of work that you might need them to do, right? So you can leverage your use of the cloud installation of Kubernetes to let your in-house staff be reassigned to things that are more mission critical for your company, as opposed to just basic physical infrastructure. Okay. One of the things about managing things in the cloud with Kubernetes is that you're not the one who's paying for the capital expenditures for those machines that sit on the racks in the cloud, right? You don't have to maintain that rack of machines locally, okay? So you can reduce your capital expenditures on equipment this way. Now, of course, they charge you for the service, right? So you have to be careful about that, but you're only getting charged for what you use, right? You don't get charged for the extra capacity that they have that's not being used by you, okay? And another kind of advantage of working with a cloud-managed Kubernetes provider is that it's much easier to keep track of costs, say per cluster, than it would be in-house, right? In-house, you've got a department that's putting up your servers and doing that kind of work, but it's harder to separate out how much did it cost for the HR department for the work that they needed done, or for accounting, for the work that they needed done that was done on a cluster, right? But in this case, it's very clear when you can put up clusters that handle certain applications, and then it's much easier to bill that back to departments if you need to. So it assists in that way as well. Okay. So now some of this you probably know already, or you kind of gleaned it from what I was talking about in the last slide. Okay. So the difference between on-premises installations of Kubernetes and cloud-managed Kubernetes installations. So for on-premises, this is what you find, right? You have the machines are on your network; they're inside your firewall. Okay, you've had to pay for them; you've had to put them up. Okay, scalability is not only costly because you have to buy new servers and buy new RAM, install them, but it's also time-consuming, right? To get twice the capacity that you physically have now in your data center, not only costs you a good deal of money, but how long does it take you to refit the data center to get that hardware installed, right? It could take months to get the data center up with that double the capacity. Okay. Also, there's a high initial expense when you're working on premises, because even before you ever put a workload on a machine, you've bought the machines, you've had to network everything, you've had to install things and test things, okay, to get the infrastructure up and running. All that costs money, and that's an initial expense. You don't pay for that kind of expense with the cloud-managed Kubernetes, well, unless you see it as being rolled in to that, right, into the per hourly charge that you are charged. Okay. When it's on premises, you need to have all the skills of setting up the hardware and the clusters and all the add-ins that you need to the clusters to do things like auto scaling and things like that. You need to have all that capability and all those skills in-house. Okay. So, and that takes even longer to get if you don't have it, right? To hire people with these skill sets it's not a quick process. Okay. But what you do get on premise is you get complete control over your data and your security. Okay, and assuming that you do have the skill sets in-house, you can handle the data and security exactly the way that you want based on your organization's needs. Okay. Coming along with you having the control over it is the responsibility for it. Okay, so you have the responsibility for the data and security. That doesn't mean that you don't have responsibility when it's cloud managed, Okay, but there are many aspects of the security that are taken care of for you. Okay, and so the ones that you have to worry about are greatly reduced in that case. Okay, and now we'll flip it over and take a look at these aspects on the cloud managed side. Okay, so when you're using cloud managed Kubernetes, um, the cloud, the hosted machines are in the cloud. The cloud service, like Google or Amazon or Azure, they handle hosting those machines. So that lowers your capital expense. You don't have to buy those things. The hardware scalability is seamless and instant, right? So you're able to scale up to double the CPUs. As soon as you can write the command and enter it into the computer, it can happen, right? Which is different than taking months to hire higher skill sets and to get a data center retrofitted for more capabilities. Now your in-house skills and resources are only needed for app management and some tweaking of security in the cloud setup. Okay, so you can take those resources that you had that were, these highly intelligent folks who can run Kubernetes, and they can be used in ways that help the company with its own mission, as opposed to just doing this generic mission of putting together infrastructure. Now, what you pay for this, of course, is you pay a fee, per unit of time for the machines that are running in the cloud. But you also pay by having a more limited control over data and security. Okay. So there are certain types of things that they'll set it up the way that they set it up on the cloud, and you have to deal with it that way. And then there'll be aspects of it that you can tweak. Okay, but you won't be able to tweak everything. And you'll have limited responsibility for cluster management, which is a good thing. So all the standard things like maintaining the clusters, making it easy to update the cluster, when you get a new version of Kubernetes, for example. All of those things are much easier on the cloud-based service. Okay, so let's go over a couple of the services that are available. Okay, and this is just a handful. These are the largest services, but there are other services out there that have their own spin on managing Kubernetes in the cloud and their own niche. So first, it'll depend on whether you already have a relationship with one of these cloud providers, and whether you want to just kind of try out Kubernetes on the cloud service that you already know about. Okay, or whether you really want to find a niche player who's doing something specific that the other ones aren't doing. Okay, so we have here on our list EKS, Amazon Elastic Kubernetes Service, Google Kubernetes Engine, Azure Kubernetes Service. All the acronyms look the same, right? EKS, GKE, AKS, IKS. IBM has its own Kubernetes service in the cloud. And one of the different ones, so that's the top tier, those top four. And then you've got other ones that are more like DigitalOcean, which is more of a niche player. And then you have some listed in the notes here. So this list continues to expand. Platform 9, OVH Cloud, Weaveworks, VMware has a play in this also as well. Okay, so what are the common features between these large players? And you'll see that they have elastic provisioning and auto scaling. Okay, so that capacity is what we've been talking about. The fact that the machines can, they have them on the rack, and you can automatically auto scale and use VMs that they spin up on demand. You can manage these services through command line utilities, sometimes one or more. So you can usually use kube control, but sometimes they'll have another command line utility that they'll handle not only the kube control type commands, but they'll also handle the commands that are specific to that service. So they might have added features in some way. So those command line utilities will add those. And they'll also have usually a web GUI or web console dashboard, something like that, that allows you to manage the Kubernetes setup. Okay. Another thing is simplified upgrades. Okay, so if you've ever upgraded Kubernetes on your own, it's kind of like this precision dance of, taking down a pod, putting up another pod, and it's in its place with a new version, and so that's modifying the versions of applications. But then think about the fact that you also have to do that for the Kubernetes itself. When it goes to a new version and you want to use features in the new version, you have to upgrade the cluster itself. And you might have to do that from multiple clusters. So most of these cloud services have a simplified way of doing that. Another thing that they've been adding in is the ability to add on-premises hardware into clusters. So they'll have like a connector that you can connect from your, say, Google Kubernetes cluster to connect it to machines or nodes on your network, right? So they're starting to do that because what they find is that in many cases it's not a choice of just having Kubernetes clusters in-house or having them in a cloud service. It's more of a hybrid situation where you have both, right? So think about, you've got your production applications running, that's a more predictable type of setup. Then you've got your development staff who's got testing to do and development to do, and they increasingly want to do that development and testing on a cluster as opposed to just a single instance of an application, in order to make sure that when they do deploy the application, it works in the clustered environment very well, right? So in that case, you have clusters that are just spun up for the development efforts, right? And those would be in addition to the production clusters, which may be in the cloud. Okay. Another thing you'll find with these cloud Kubernetes providers is integrated support, where things that are required in Kubernetes can be satisfied by other services that the cloud provider has. Okay? If the cloud provider has authentication and authorization services, okay, they can be used with their version of Kubernetes. Okay, integration with continuous integration and continuous delivery application development systems. Okay, if they have systems that do that, most of them do, they can integrate that with Kubernetes. Same thing with the load balancing. There's usually a load balancing feature or service apart from Kubernetes that can be brought into Kubernetes and used in there. Okay, and then whatever networking features they have can be used in implementation of the Kubernetes clusters as well. Okay, so one of them that we can go over, we won't go over all in all this detail, but just to get a picture of what one of the services offers and how it works, we'll take a look at Elastic Kubernetes Service, the one from Amazon, well, EKS. Okay, so the service, this is some of the things that it does. Provisions and manages Kubernetes control plane and worker nodes. Okay, so it's nice that it provisions them, right? So you can, fill out a form, press a button, and it will actually create the cluster. Okay, if you've ever created a cluster from scratch, where you had to go to each, bring up each node, go to the nodes and load things on them, you know that provisioning is something that you don't want to do from scratch. And then managing the control plane and the worker nodes can all be done from the service, like I said, through their command line utilities or their GUI. The service also scale and manage and secures the control plane in high availability mode, right? So the idea here is that you build the cluster so that you can start applications running, okay? And those applications can be clustered. But think about it, the cluster itself, the way the cluster runs, is a cluster itself, and it requires management, okay? So you need to manage it so that if one part of it goes down or breaks, or the node that it's on goes down, that it doesn't keep the cluster from running, right? So you need to have high availability mode and management of the cluster. You may have up to, you may have 3 nodes or more involved in the cluster itself, so that it can be spread around and things won't break if one thing goes down. Okay. This is something that is usually extra work when you're doing a cluster on your own, right? You're like, oh, okay, I got the cluster up and running. That's great. Oh, now I got to bring it up in HA mode. It's more work, right? So they take care of doing that. So EKS supports Linux nodes, ARM nodes, Windows Server, okay, and also Amazon machine images. So what they do is they provide this machine image that's optimized for use with Docker, and you'll find that other cloud providers have something like that as well, some other offerings, usually a version of Linux that they've thinned out and taken out the things that aren't absolutely necessary, so that it doesn't use up any more RAM than it needs to, and doesn't use any more CPU than it needs to. Okay. So let's see. So, and what you see there is, so those are the things that it can manage in terms of nodes, okay, but all those types of nodes are provided as EC2, or EC2 is the name for the type of resource that allows you to spin up a new machine, right, on Amazon Web Services. Okay. Okay. Then you have EKS add-ons. Okay. So this is a case where there's extra capabilities built into these add-ons that you can add for observability, which is really logging and metrics, right? Scaling, to have custom scaling, networking plugins, integrations with other resources in the AWS cloud. Okay. So these add-ons provide a lot of value for you to use other parts of AWS in your clusters. It just makes it easy to do that. And then in some cases, just provide some extra capabilities. Okay. So here your cluster can be managed again by the EKS control command tool, by the GUI, and the AWS CLI. If you've worked with AWS before, you know they have a command line interface that you can do most anything in the AWS cloud with. Okay. And that gets extended with the ability to handle the clusters that you bring up under EKS. Okay, so you'll have the types of nodes. Okay. Managed nodes, these are the ones that are deployed to EC2 instances, typically Linux. EC2, again, is the standard way that you create a machine in the cloud on AWS. You can also have a node type called Fargate. It's a technology that they have with AWS. Allows you to deploy pods without concern for the instance that it's on. Okay, so just like you might have seen serverless serverless computing or serverless services like lambdas, where you just put up like a function or something like that that runs, and you never have to deploy it to an instance. You don't deploy it to a machine or a virtual instance. you just tell the cloud provider, here's the piece of software code, I want you to run it, okay? And it's abstracted. You don't have to deal with where it's going to be run, okay? Because what you're interested in is, one, that it's running, okay? And two, that it's accessible via the network. And those two things are given to you in serverless computing. So when they run it, you can make network calls to it, and your clients can make network calls to it, and it'll do what you want it to do, okay? Without you having to know where it's running, okay, or even what instance it's running. So that's the Fargate, allows you to do that. So that one of your node types can be a Fargate node. You can have Windows nodes. You've also got BottleRocket, which is a Linux-based OS, and it's from AWS. Okay. And let's see. Okay, and then you've got these others, Elastic, and these things are not nodes. These are just other parts of your Amazon EKS, okay, or things that work along with it. The Elastic Container Registry allows you to securely keep your container images, okay? Because if you build an image for an application that's an in-house application, you don't want that to be on a public registry, all right? So you want it in a registry where it can be locked down and not accessed by anybody but your team. So the Elastic Container Registry is part of the Amazon Web Services that allows you to save those images, okay? Now there's also an Elastic Container Service, okay? That would be something that you can use to spin up containers if you wanted to just, for example, spin up a Docker container and not have it be part of EKS, right? So if you're not using a cluster and you just want to, bring up some container, you can use this. So it's a simplified version of what you'd be doing with the cluster. And the billing that you have is going to be based on the usage in the machines, except for Fargate, which has a different. It's still a usage-based thing, but there's no EC2 instance, so it's a slightly different way of billing. Okay. Now the Google's Kubernetes engine, this is a separate one. We won't go through it in as much detail as the last one. Okay, but I just want to give you an idea of the flavor of these different Kubernetes offerings. Okay, so Google pioneered Kubernetes. Okay, they're also the biggest supporter of Kubernetes in the open source world. Okay, so you can imagine that they're kind of on the forefront of a lot of what's going on with Kubernetes itself, and with stitching that into their own service, the GKE service. Okay. One of the things that they offer is you can set up your nodes in standard or autopilot, or your clusters in standard or autopilot. A standard is you have full control over your nodes and setting them up, and scaling them and things like that. Okay. But then they have an autopilot mode, which will introspect your cluster and look at the traffic and things like that, and will automatically scale and descale things as needed. Okay, so you can always start off an application in autopilot and move it to standard if we want more control over that, or you can tweak the autopilot settings. Okay. Again, billing is, in their case, is also based on something that's usage-based, but it's per pod as opposed to per machine. Right? So some of the things that make GKE a little different are the fact that you've got some pre-built templates for deploying certain types of applications. Like there may be standard database applications that if you want to deploy them, you just have to click on the template, okay, and it'll deploy that into your cluster. Okay, so that's something to look into, save you some time and not having to worry about setting up those things yourself. It's kind of like a halfway between you doing it locally and having a software as a service database where everything's already set up and you're just using part of it. Then there's something called Anthos, which we'll get into a little bit later in more detail, which is a multi-cluster management. It helps you. One of the things it can do is if you have clusters that are set up to use virtual machines as nodes, so maybe that you've already set up a whole lot of stuff in-house and you want to convert that to using things in containers, okay? They have a migration utility that works in that way, okay? That makes that process easier to do. Okay? And they also do something different by providing a sandbox for the clusters so that it's an additional way of adding security so that you don't somebody doesn't find another way, a backdoor into your cluster. Okay, so it's something that they have and it's not implemented on other engines. Okay, so Azure, of course, they've got their own service. They have an integration with Active Directory. Active Directory is huge in enterprise as a way to keep your authentication and authorization information. Okay, so the fact that you can integrate with that with your Azure Kubernetes service is kind of like one step forward, or you've already got part of your work done. Okay, because you don't have to re-implement that in a different way. Okay. This is one of the services that also implements Helm, okay, which we'll talk about in one of the other sections today. Helm allows you to set up applications and change application versions and things like that, upgrade them and roll them back much easier. Okay. So they roll that right into their service to make that aspect of working with Kubernetes easier. Okay, and of course they have integration with Visual Studio Code, okay, tools that makes it easier to work on your clusters through that tool. Okay, so one of the ways of working with Kubernetes, of course, is to create your applications using YAML files, and those YAML files, unless you go out of your way to version them, you might just have them in a directory somewhere and then you run them from the directory. But kind of a best practice is to use something like GitOps workflow where you're keeping those YAML files in a source code repository where they can be diffed, you can change versions, things like that, and reapply them. Okay. So those things are worked into that integration. Okay. IBM has a cloud Kubernetes service. So one of the security features which is unique to them is continuous scanning of the container images. Okay. So remember, the container images are what are used to run the containers. If there's any problems with those images, they're not secured, and somebody substitutes an image into your repository, and then you start using an image, they could have any kind of backdoor hidden in that false image. So the scanning of these container images is an important security feature. Okay, and IBM is also set up to identify weaknesses and different vulnerabilities based on work they've done in other aspects of the IBM consulting. Right. IBM uses Istio service mesh, which is also a standalone. You could use it with your own clusters, okay? But they integrate it into their service to allow microservice-based applications to be easily connected to the front ends for those applications. Okay, and to the back end. So the front end to the back end to microservices, microservices database, whatever you need in terms of connectivity, that makes that easier. Okay, and IBM also has strong continuous integration and deployment tools that are integrated with their Kubernetes service. Okay. Now DigitalOcean's a little bit different. It's started off as a developer-focused platform. So one thing about Kubernetes is that it lends itself to the development workflow. You know, where you're doing continuous integration, continuous deployment. So it can be a tool that even if the rest of your organization doesn't use clusters, it kind of makes sense to use them in development. Okay, so they're a development-focused platform. They handle that marketplace or that market. They also have one-click apps, similar to one of the other providers we mentioned. So you can go to this DigitalOcean.com and just pick an app that you want loaded and load it up into your Kubernetes deployment. Okay, so if you want a database or you want some kind of special networking setup, you know, instead of you having to know everything about how to get that up and running, you just click the you click on the app and then it loads it and you use it. Okay. And then also the getting started, they make that easy by walking you through the configuration options. Right. So as you've worked with Kubernetes or any of the cloud services, you'll notice that each service has many different settings. Something as simple as a data volume, okay, that you think, well, that's simple. It's a directory full of data. It still has, you know, dozens of settings, so they can be confusing, especially when you hit a setting that you haven't seen before. Okay, so this guided configuration helps out in that case. Okay, so here on the next two pages, we just have a table that we would have put on one page if we knew it would have been formatted like this. It would have all fit, but here we have a couple of aspects of these different services shown in the table. So for EKS, that's Elastic Kubernetes Service. The virtual machines are EC2. Its container registry, where you put your images, your Docker images, is going to be called Amazon Elastic Container Registry. Its serverless container is called Fargate. Multi-cluster management is done through EKS Anywhere. Okay, and they have an alternate container management ability where you can just spin up containers apart from a cluster. Amazon Elastic Container Service. Okay, so those are the things that we're showing for each of these. Okay, for GKE, you just have different names in those slots, right? They have artifact registry, right? Their multi-cluster management is called Anthos. Okay, their serverless container is called Cloud Run. Okay, so sometimes it's just hard to keep track of some of these things when you are looking into a new service and try to figure out, well, you know, I know that they have some way to do serverless. What is it? Which of the buzzwords that are related to that particular Kubernetes service is the one that you're looking for. Okay, and here we have the same information for Amazon Kubernetes or Azure Kubernetes Service and the IBM offerings. Okay, so you can see, you know, what the names of their products are that do these various that take care of these various topics, right? Serverless, multi-cluster, etc. Okay, So before we go on to the next section, just want to kind of summarize. So we're talking here about when you want to start moving or if you want to start moving your applications into a cluster that is in the cloud, handled by one of the cloud service providers. There are reasons to do it. A lot having to do with the capacity, the ability to spin up capacity at any particular time when it's needed. Okay? That's part of it. The economic equation, that you don't have to build out a data center in order to use this capacity. And that's also something that's helpful. And then there's certain integrations with other tools within those cloud services that make it useful to do that as well. Okay? So if you haven't done that, then you'll start seeing that happening. In some cases, you'll see that there's certain in-house Kubernetes clusters will stay as in-house or on-premises, just because it gives you more capability to control certain things. But that other ones over time may be migrating to these services. And I think part of it is, as well, would be the every organization has an interest in security. Okay, and for the longest time they had a firewall, and anything that was really important was behind the firewall, where only they could get at it, or somebody'd have to break into the network to get to it. Okay, but more and more, because of these different offerings, like the cloud offerings here for Kubernetes, it starts to be, there are advantages to having something in the cloud that outweigh that need to have everything behind the firewall, right? So some organizations release that concern earlier, and they move to the cloud faster. Okay, or other ones, are maybe behind a little bit in holding on to that need for that kind of security, because the security is possible in the cloud as long as you keep an eye on what services you're using and how you're using them. Okay. Okay, so the next thing we're going to go to is application and package management. Okay. And there's a couple of different package management solutions, but none are as kind of like used on a widespread basis as Helm. Okay, Helm at this point, if you haven't used it, is almost a part of Kubernetes. It's something that, as you'll see, just makes things a lot simpler to work with. It doesn't make anything that you do in Kubernetes old-fashioned. It just adds capabilities to it, so it's not obsoleting anything that you already know. Okay, but it just lets you control the deployment of applications with a certain amount of ease. Okay. So if all of our applications were just standalone or monolithic applications, meaning that they didn't need anything outside of themselves to run, then you might not need something like Helm. Okay? But most modern apps are a combination of several different types of applications that are running. Okay, you'll have a front-end application. Maybe it could be written in Angular. It could be written in React or something like that. Well, there's several frameworks like that for front-end. You can have a back-end or middleware server. You can have a data store or database, microservices. This is all different kinds of services that then come together, are packaged together and you have to bring them all up in order for the application to run. Okay. So what that means when you're working with Kubernetes is that you're going to have to set up profiles for each of them, set up configurations, YAML files for everything, and then run all those things separately and do them in whatever order is needed by the application so that it can get up and running. Okay. So that's where, that idea, that landscape of having multiple applications really coming together to provide one particular service that you're doing, whether it's accounting or something having to do with your shipping department or orders or e-commerce or something. It's always multiple applications coming together. Okay. So Helm is a package manager, okay, for Kubernetes and for running applications in Kubernetes. So it lets you manage, well, Kubernetes by itself, you can manage application containers. Okay. But in addition to that, if you've used Kubernetes, you know that usually you have to bring up at least a one container plus a service. Okay. Plus you have to, if you want it to scale, you might have to set up a group that things can scale in. So you can mention how many replicas you want, a replica group, that kind of thing. So there's, even within Kubernetes, for one application, you could have several different resources that have to run. What Helm does is brings all that stuff up at once. So you put together a profile or a package, and that package then runs. So what it does is lets you find and install, run and maintain multiple Kubernetes applications or Kubernetes resources, okay, like services. A service is, there's no container for the service. It's a way of networking your application, right? But you still have to set it up, right? So that's one of the types of resources that can be bundled into this Helm, a single application. Okay, so it lets, one of the also benefits of using Helm is once a package has been set up, or what they call it a Helm chart. Okay, that packages all those different pieces together. Then anyone can start the application or stop it or upgrade it or roll it back if it's been upgraded. All those things can be done by somebody who has less understanding of the specifics of the application, right? So what it means is that the folks that are involved with deploying applications, they don't have to, reskill on every application that's built. They can just say, okay, we're going to use Helm. Then the application developer is going to help us create the chart. And once we have the chart, we can easily use it to provision the application, okay, to bring it up and run it and upgrade it. Okay. So that's one of the advantages. Okay. You use Helm has a command line interface. You use the Helm executable, okay, and then you just run Helm this, Helm that, and we'll see some of those commands. Okay, and then there's also something called Helm Hub. It's a place where you can store charts. Okay. So what Helm can do, it bundles multiple Kubernetes apps and or resources, things that are objects within Kubernetes. You can publish these app bundles or charts. That's what these bundles are referring to. You can share them, okay, amongst, one department needs to run it, another department needs to run it on a different cluster. You can just give them the chart, and that'll help them set it up. You can update bundles using that. So once the application is running, okay, then you can easily just update the application to a new chart version, which could change the executable or something like that to a new version. And you can roll back. Okay. So one of the things I like about Helm is it doesn't overreach. It does these things and it does them easily and well. And it doesn't try to be, all kinds of other things. It knows that this is something useful, so that's what it does. Okay, so let's talk about some Helm terminologies that we can discuss Helm. Okay, one, so Helm's the name of the project. It's capitalized. The Helm CLI client is the word Helm lowercase. A chart is this package that you can create. It's like a blueprint for an application installation. Okay, and then you have let's jump down to release. When you take a chart and you open it in a Kubernetes cluster, what's running there is called a release. So you see some of this is parallel to what you see, for example, in Docker, right? Docker has images, okay, and then when you run an image, right, you get a container, and that's the runtime version of the image. So here, when you run a chart, you get the runtime version of it, which is when it's actually running, called a release. Okay, and a repository, you can have a repository where you save your charts and you retrieve your charts from them. And there are some standard repositories for charts that are standard, right? So let's take a look. Okay. Well, okay, before we do that, we'll just talk about installing it. Helm is a pretty simple installation. You should have your Kubernetes running and your kube control running. Okay. You can install Helm by downloading an archive file and running it, okay, unzipping it. You can use an installation script. I find that to be one of the easier ways for the work that I do. You can do it by package manager, right? So if you're on a Linux machine or some other machine that has a package manager, you can just run the name of the package manager app install Helm. Now, the one thing I've always found with package managers is that you're not guaranteed to always get the latest version, right? I don't know if you've had that experience as well, but that is a concern with that. You want to make sure you're getting the version you want. So once Helm is installed, you just do Helm version. It tells you the version of that, so you know that it's been installed. Okay. There's development builds, for advanced functionality. If there's anything new that Helm is doing. Okay. So here, for more information, you're going to go to helm.sh. Okay. That's your location for Helm, and we'll take a quick look at that. Helm, okay, let's go here. So this is helm.sh. We'll turn off this bookmarks bar. Okay. So it's easy to go here, and then installation. Here's an example of installing with a package manager. So you can choose, like GoFish or something. They all look pretty much the same. And then you can go here to get charts. Okay, but we'll show another way. You can open up or download a pointer to a repository that has charts in it, and you can do that all from the command line. If you go here, okay, and just the prototypical installation that everybody knows about, it's almost like the hello world for Kubernetes is Nginx, that web server. And here you type in Nginx, and you'll get a list of different charts. Okay, the chart that's most people use for Nginx is the Bitnami chart, right? But there's others that you could choose from. Okay, and then let's see. So if I click on this, let me see. Oops, I'm clicking on the wrong thing here. I want to get to that main page for this Nginx. Okay, so here, when you click on the chart, here you can take a look and see there's ways to install it. Gives you information about it, how many times people have been using it. Okay, if you want to install it at the command prompt, you can do that, okay, uninstalling the chart. So all the information is there. So the GUI for this is kind of nice. Okay, but there's a lot of other capabilities and documentation and things like that on this site. You can go to the let's see, this should be the beginning quick start guide here. Okay, but we'll go through a little bit of that. Just wanted to show you that site. Okay, so the first thing is this Helm install, right? So this, what it's doing is basically getting some content for Helm in this shell script, and then you run the shell script and it installs it. Okay, you just copy these lines exactly as they appear on the getting started pages, and it installs it. Okay, I like it because I don't have to figure out whether or not the version is an older version on a package manager. Okay, so if you want to look at other ways to install, of course you'll go here, and here's your installation page where it gives you that script I just showed you, or go through package managers. You know, it gives you all the different ways you can install. Now, one of the things you want to do is add a repository, okay, to your local setup. Okay, and then you can use Helm search. Okay, so if we take a look at this, let me bring this down here. Okay, so we do this. We do Helm version. Okay, it gives you the version, of course. Helm repo list. Okay, so you can see that I've installed this one repository locally for use with Helm, so that when I do Helm search and I do something like Nginx, let's see what doesn't like there. Oh, it should be search repo. So Helm search repo Nginx. It'll go up to the repo and it will bring back a bunch of Nginx charts that you could use. Okay, so you see that down here, Bitnami chart. This is the Bitnami repo, so of course all the charts are going to be from them. So you have the name of the repo and then the name of their chart. And then there's different versions for the charts, and you can see the app version, right? So if you go to a different chart version and install a different chart version, you'll get a different app version. Okay. So that's just looking through them. So if I wanted to install that, well, we'll get to that in a second. Let's go back to our thing here so we don't miss anything. Okay, so you add the repo, Helm repo add, Helm repo list. It shows the repos. We have the Bitnami repo. Okay, you can update the repository. So if I installed it last week, I want to update it, I can do that. Or I can remove it if I don't want to search through that repository anymore. Okay, and here's the process for adding it. Okay, you add it, then you can list it, then you can search it, okay, and then you can install a chart. Once you've installed a chart, which is just done with install, you can list the charts that have been installed, which are now these resources. I'll get it in a second. But then you can uninstall it as well. But we'll go through that. Okay. So here's an example of searching. This is what I did when I opened up that terminal for you to look at. I searched for Nginx. This is searching for DB. So here's a bunch of DB charts. Maria, MongoDB, all the standards that you might be interested in. Okay, so we'll take a look here at installing charts. Okay, so let's start with this Helm install my web. That's going to be the name that you're going to give it when it's running. Okay, and then this is the name of the chart that's being installed. So let's run this. Copy that. We'll clear out the screen. Oh, and I might as well show you. Let's get rid of that, and let's go here. Okay, so here is the Kubernetes cluster. This brought up in dashboard. Okay, and the reason I'm doing this, it just makes it easier than continuously typing the CLI commands for you. Okay, but if I look at deployments, there are no deployments. Okay, I look at some pods. There's a Kubernetes pod, or there was, but there's nothing running there. So we'll see that change when we install this here. So Helm install MyWeb. So it's going to be called MyWeb. It's an Nginx installation. So we just run that. I just hit enter on it. It'll take a second. And if I go over here, it's already done. Okay. And now I go here, and you see that it's immediately here up and running. Okay. And then if I go down, I'll see that there's a service that was created as well, the MyWeb Nginx service, which has an external endpoint. Okay, so not only did it set it up, but it set it up, the networking part of it was set up as well. And I can take this and copy it. Well, I'll just click on it. So it brings it up here. Welcome to Nginx. So it means that your Nginx server is running, and it was just brought up from that one command. If I go back to here, I can do the same thing with a curl command. Curl, paste that number in there, paste. That's the external address. It's port 80, so I don't need to put the port on there. Okay. And it's a little bit hard to read this, but basically it's saying welcome to Nginx. If I do this, I can just say, do a little Linux stuff and grep Nginx. Makes it a little bit easier to see what's happening there. So we have the Nginx title page coming up. Okay, so it means the thing is running. And I can take a look at Helm list, and it'll show me, here's my deployment. MyWeb is the name of it. Okay, and it's got this app version 1216. Okay, if I want to look at the status of it, I can do Helm status MyWeb, which was the name we gave to it, and it gives you this, which, if you were sharp, you also saw when we first created it. It output this information to give you some idea that it's deployed. It's at revision 1 currently. The app version is this. The chart version is this. Okay. And then it tells you some information, and here it gives you some help in figuring out the URL that you would use for it. So you can just take this, copy and paste it. If you don't want to use the way that I used, you can just do this. It'll run that, and it'll show you this is the URL. Okay, same URL as we got before. If I copy it correctly, I can then do the curl on it. Okay, same thing as before. Okay. So as you can see, it's very easy to bring up an application using this. Oh, I didn't need to go there. We need to go here. Okay. So we did status, we did lists so that we could see which things were currently running. Okay. You can also use your standard kube control commands to get information on the pods and the service. Okay. Let's try these just to verify that when it brings it up, it's really launched in Kubernetes the same way as if you had run everything from scratch. Okay, so here it gives us this pod, MyWeb, Nginx. There's the pod name. Okay, and what was the other services? I think we were looking to look at service. Okay, and here you see the external IP address. It's the same, the one that we got from the dashboard. Okay. Now charts can also be uninstalled fairly easily. Just do Helm uninstall, and this, give the name of it MyDB, and it'll take down everything that it put up. Okay. But before I do that, I want to show you what's happening on the next part, is upgrading a release. Okay. In fact, what we can do is we can kind of follow this. First thing we're going to do is go and take down this release. So again, I'll show that it is up and running here. You know, we've got it as a pod, we've got it as a service. Okay, so it's up and running there. And if we do Helm uninstall my web, which is the name I gave to it, it says uninstalled. Okay, and then this should go away. Yep, that goes away, the service goes away. Okay, now this is a fairly simple one. There's a service and an application, and that goes into a single pod. But it works the same way if you have multiple applications and other types of settings that are required. Okay, they all just get brought up and cleaned up later on. But the reason why I took that out is what I want to do is I want to install this, and I want to install a certain version. Okay, so we'll go here, we'll go paste this. I want to call it my web again, just because I feel like that. And this is going to install the version 5 of the chart. Okay, so now we should be able to see with pods. Okay, now I'm looking for we need some more information, so let's go back to here. Okay, and we want to do Helm list. That's what we want, Helm. Okay, and you see over here that the chart version is Nginx 5.00, which is this Nginx version, 1.16.1. But now, just say I want to upgrade that to do another version. Let's go back to here and take this. So this time we're going to do an upgrade, but we're going to do to version 6. Okay. So we'll go back to, we'll clear this, we'll go back to here. Instead of install, we're going to call it upgrade, and we're going to change it to version 6. Okay, it should come back momentarily and tell me that that's the case. Okay, so it came back, it was deployed, but let's check it with Helm list. Okay, so now we see this is chart version 6, app version 1.19. It was 1.16 before, and it's revision 2. But if this isn't enough, I go, oh, well, I really like the original version. That was working well. Let's get rid of this. We can roll it back. So it should be rollback. And we could give versions and things like that, but this should be enough. Roll back my web. And it says it's rolled it back. And I can do Helm list. And you see now it's back to version 1.16.1. Okay. So it makes it look like it's just, you know, like it's easy, but there's a lot going on in Kubernetes when this happens, right? It has to change the settings in Kubernetes. Kubernetes has to act on that, has to go to the pods, it has to get rid of the old one, it has to upgrade it to the new one or roll it back, okay? And the interesting thing here is we've done 3 things. We've done install, upgrade, and then we've done rollback. So we're at version 3, revision 3 of our my web application. Okay, so the revisions go forward by number, even if the application versions change. Okay, so now we did this with a simple one replica application. But if our application had 5 replicas, it would have worked exactly the same way, right? We could just roll it forward, roll it back. It would take care of stopping those one at a time, starting new ones one at a time. All of that work would be done for you. Okay. So this is some of what makes this much easier to work with, okay, than just doing things from scratch in Kubernetes. So this was the rolling back of the release. So you install, you upgrade, okay, and you just do rollback. And in here, notice that there's a 1 here. If we had had 10 versions of the application, so we upgraded, okay, up to 10 times, we could roll back to any one of them, okay. In this case, we're just rolling back to the one that was labeled number 1, the revision number 1, okay. But if we had had 10 versions, we could have rolled back to number 5 instead of number 9, or whichever one you want. Okay. Now, what we showed you was working with a chart that's a standard chart for a standard application. Very simple. It's a web server application called Nginx, right? But the real power comes in creating your own charts for applications that are unique to your organization, okay? So when you go to create a chart, you start off by creating a chart with Helm chart, Helm create, and then the chart name. What that really does is it creates a directory with the name of the chart, which has a bunch of files in it that then you'll customize, okay? So this is what it creates. It creates this, in this case, we do Helm create my app. It creates a directory, my app, and it creates all these files, okay? And then you'll go in and customize these files for your application that you're trying to install. Okay, and for that you can take contents of the YAML files that you use when you load up your application by hand, manually. You can take the contents of those and populate these the various files here, and this will then be your chart. Okay. So to install a custom chart, first you would create the chart, customize it. Now, one thing to be said about the charts is that when you create a chart, it's actually a valid chart. It doesn't install the application you want. You have to customize it for that. But it is an installable application. So if you just want to try custom charts and see how the process works, you can create one and then immediately install it. Okay, so we go Helm install MS app, my app, the app you created. Okay, and that would install that particular chart, okay, and all of the resources that it specifies. Okay, you will probably also want to package your charts so that you can pass them around to other departments or put them in a repository, right? So you can say Helm package, and then you do my app. Now, while you're working with this, after you do Helm create my app, okay, it's going to create that directory in a subdirectory of the directory where you are. Okay, so you've got to make that your Helm working directory. Okay, and think about it as you're creating a Helm project. So it's kind of like your project directory. You go back to that directory and then you can package it by using its name. But if you go to another directory on the machine and you try to do package, it's not going to know where that is. Okay, so you do Helm package from within the directory where you created it. Okay, and this creates a tar file, tar gz file. Okay, and then you can install directly from the tar file, right, by using that as the name of your chart. Okay, it's also possible to sign them if you want to sign them so that it can be verified that they haven't been tampered with. Okay, there's more information about the whole packaging setup here at this location. Okay, and again, before we go to the next section, let's just talk about what the advantages are here, right? So you have this ability to either use standardized charts for standard applications, okay, which are in repositories. Okay, you can use that and simply put up an application very quickly. If you want to package your own application, you can create your own chart, okay, and customize any aspect of it, including the applications that are loaded, the resources that are loaded, the services that are loaded, okay? So that once you're done creating your chart, and you should test it, then you can give the chart to anybody, and they can simply bring up the application and take it down and upgrade it in the same way I did with the Nginx application. Okay, so that's it's great because you're packaging all the intelligence about how this works, about how to set up things in Kubernetes. You're packaging that into this Helm package. Okay, and then anybody can run a Helm command. It's Helm install, Helm uninstall, Helm upgrade. So anybody can run those. Okay, once everything's been packaged once into one of these Helm charts. Okay, so that's very useful. If it's something that you're not using, or you just use a little bit, you should think about incorporating that into your workflow. Okay, the next thing we're going to look at is multi-cluster management. Okay. So we'll take a look at what it means. What is that? What are the use cases for it? Why would you be doing it? Why would you need to do it? Okay, and then look at some of the tools that are involved with that. Okay, so this multi-cluster, multiple clusters, right? Your organization runs multiple applications for multiple reasons to run your organization. So it would make sense that you would at some point be running multiple clusters, okay, to run those. Okay, so this idea is that in some cases, you just need to run multiple clusters to run different applications. You can have one in each cluster. Okay, but there's also the possibility, if you have multiple clusters, right? Why can't I run, one of my pods for the cluster? For this application on one cluster, and run another pod for the application on a different cluster, right? Maybe I want to do that, and you'll see that there are reasons why you might want to split an application like that over different clusters. Okay. Okay, so the idea is to have multiple clusters, and then use them in whatever way is necessary. Okay, so this multi-cluster management is managing those multiple clusters in an easy fashion. For example, from a single user interface, right? And that this single user interface for multiple clusters can be helpful in a bunch of ways, right? You can, maybe set up all your role-based access control. You set all that up for all the clusters from one interface, okay, instead of having to go to each cluster and set it up separately. So that's just one example. So one of the user groups that is going to find this most useful is a platform support team. The ones who deploy your applications. When you're finished developing it, if that's what you do, then it has to go to production, and there's going to be a team of folks, the platform team, who takes care of doing those tasks. And if they have 20 clusters to handle, it's just much easier if they can handle them all from one place. Okay, so it helps them manage the complexity of those multiple clusters. So So what are the use cases? What are the reasons why people are running multiple clusters? Okay. One is hard isolation, right? And for several different reasons, you might want to have things running in separate clusters. Okay, this can address what you see here, performance issues. You know, if you have two clusters up and running with the same application, you're using more resources, you can handle more throughput. Okay, if you have something in one cluster and then you put something else in another cluster, they don't, unless you do something special, they don't see each other, right? So you can secure applications by giving them their own cluster. If there are compliance issues where you're not allowed to let certain data have, be mixed with other data, then you might want to, run something on an isolated cluster or a cluster separate from where your other applications are running. Okay. Another use case for multiple clusters is when you're running in a multi-region situation. Okay. Now, anybody who's worked with the cloud providers at all knows that they have data centers where they're, where they have racks of this equipment that runs your application in multiple regions, right? So you don't just have one place where this stuff is going to run. You usually have to tell it, I want to run this stuff in the East region, or the East region, the Southern East region, or the Western region, something like that. Okay, so you may want to run the same application in multiple regions, okay, just so that it's closer to the users, right? So if you have a bunch of users on the East Coast, why would you want to make them network all the way to the West Coast to access your server, right? And the server on the West Coast is better to use that to handle the traffic that you have on the West Coast, right? So that's just one reason why you might want to have your application in multiple regions. And of course, if you have something in multiple regions, chances are those are going to be separate clusters. You're not going to have a cluster, with a node on the East Coast and a node on the West Coast. That seems kind of, there's going to be latency issues and problems there. So you'll have a whole cluster on the East Coast, in the East region, a whole cluster in the West region. Okay, and that could, suit your application needs. So what I was describing there is one scenario in multi-region, which actually is the next one that's listed here, geocentric workloads. Okay, so you're managing workloads closer to the end user, right? It's also referred to as edge computing, right? Where you run something so that there's less latency and better user experience by running it closer, physically closer to where the users are going to be. Okay, so that's just one multi-region use case. Okay. You may also want to have this set up because you're using more than one cloud provider. Okay, so you might have one cluster on one cloud provider, like on the Amazon cloud provider, another one under Azure. Okay, and this could happen for a whole bunch of different reasons, right? One reason is something that happens fairly often now is companies merge, and one of the companies that merges, is using one cloud provider, one's using another, but now they have to merge all their operations, and that's going to take some time. So they may or may not want to unify everything under one cloud provider. If they're using two cloud providers, okay, then they might just keep on going with that. Okay, so now you have another case where you have a cluster in one cloud provider and one or more in another one. Okay, you may also want to separate things into separate clusters, be it wherever they are, right? For safety reasons, right? You might have applications, especially if they're testing or they're new or they have the usage pattern is hard to tell at first. You don't know how much traffic there's going to be for the application, and you think that it might break and bring down a machine or bring down a virtual machine. You can put that in its isolated in its own cluster, okay, separately, even location-wise from others, so that it doesn't cause any problems with them, right? So that's another thing that you can think about as a reason for having multiple clusters that you have to manage. So if you have these needs, it's a good thing that there are some tools that'll let you handle this situation. And one of the tools is called Rancher. We'll take a quick look at that. Google has one called Anthos. Amazon has EKS Anywhere, though that's a little bit different. We'll see why that is. And on that chart that we had earlier, we saw the different multi-cluster management tools provided by different cloud vendors. Okay, and there's more tools every day of this type. Okay, that they basically sit on top of your clusters and then manage them. Okay, or allow you to manage them. Okay. So Rancher is the one that most people would think of in this category. Right? You can manage thousands of clusters. Those clusters can be on-premises. They can be in any one of the cloud vendors' clouds, and you can connect to them and manage them all from the Rancher interface, or from using the Rancher command line tools. As far as deploying those, it doesn't make a difference if you already have the cluster or whether you want to launch a new cluster. Rancher can do both, right? It can do what's called deploy, which creates a new cluster that you can then work with, or you can import an existing cluster. Okay, so you point to that cluster. You do have to install like an agent on the cluster so that it's fully integrated with Rancher. Okay. Now, Rancher also has one of these application catalogs that uses Helm, so that it's kind of like the one-click install services that you saw with some of the cloud providers. Okay, so that comes along with Rancher. If you want to load certain standardized application, you can do it easily. Okay, Rancher is open source, but of course, like most open source software, there'll be the ability to buy different types of support for that. Okay, these are some of the things that Rancher does. It will centralize the management of all these things: authentication, role-based access control, monitoring, logging, things like that. So in addition to managing, meaning, so what does managing mean? At first, to me, it means, okay, I can import the cluster, I can start the cluster, I can stop the cluster. Those are some basic things, but what else do you want, right? Well, these are some of those things, right? You want to be able to have the authentication mechanisms handled in Rancher, so that it can take care of that for all of the clusters. Okay. You want to set up roles there as well, because you may have the same role needed on two different clusters. Because those two clusters are handling the same application, it would just make sense that you would have to set up the same RBAC information on both of those. Okay. And the same thing with monitoring and alerting. Okay, normally monitoring is meant to produce alerts that then come back to some human involved with the situation who can take action. Okay, so you want that to come back to one person. You don't want to have 25 different clusters, each sending or not sending their alerts. Okay, you can have them all going through one place. And logging can be set up so that all of the logs can be sent to a log server, where you can then just log into the log server and have access to logs for any of the environments, no matter where they're living. So what are the components? How is this possible? How does Rancher do this? Well, it starts off by having its own API server. Okay? You can think about that. There's Kubernetes has its own API server, so it's a similar. This has a similar architecture. Okay, and just like Kubernetes, it has its own data store. Okay, which manages the data, the configurations that you set up in Rancher. Then it has what it needs to connect to the clusters, which are cluster controllers. Okay, and the cluster controllers are going to be loaded on the control plane, the Rancher control plane, right? So it'll have one controller for each cluster, and then on the clusters themselves, the cluster control planes, each control plane is going to have its own cluster agent. Okay, so those will be in contact from the Rancher control plane to the cluster control plane. It's going from the cluster controller to the cluster agent. Okay, so here's a diagram of that. So here's your Rancher server or your control plane. You've got your API, its data store over here to the right. And in this case, it's got two cluster controllers. And then you have in another location where your cluster control plane is, you have the cluster agent, okay, which talks to the that particular cluster's API server. And the same thing here for for the other one, cluster controller 2 for cluster 2. Okay, and you'll see here they also give you some other information. This one here is running on the Rancher Kubernetes engine. So this one was deployed, created a cluster created by Rancher. This one was brought in from Amazon Kubernetes service. Okay. So the cluster controller. Okay. Again, there's one for each of the managed clusters, and these controllers exist on the same machine as the Rancher API server. Okay, so it's control plane. Okay, so what it does, the cluster controller, it watches for resource changes on the clusters. So it talks to the agent on the cluster and looks out for changes. Okay, if the configuration at the cluster is different than the configuration that Rancher has, okay, then changes are pushed down to the cluster, which are then implemented on the cluster, right? So if certain things are removed, like you delete an application, it'll delete the application down on the cluster, okay? So that's kind of the story of how Rancher is working. Okay, there's other details about how it sets up to work with each type of cluster. Because remember, if you have a cluster that's on the Google's platform, accessing it's going to be a little bit different, going to require different drivers than if you access it on an Amazon platform or an on-premises platform. So those would be details of the control situation. The cluster agents are the other half of that communication, right? You've got the cluster controller talks to the cluster through the cluster agent. Okay. So the agents connect directly to the API of the Kubernetes cluster. Okay. Just like anything else controls a cluster, like when you run kube control, it goes through the Kubernetes API. When you use the dashboard that I showed you earlier, that goes through the API. So working with a cluster is always through its API, and that's the same thing here, right? The cluster agent is going to be talking to that API. Okay, so it's going to manage the workloads, create pods, deploy things on the clusters. Okay, it's going to handle all of that. It's going to set up security, roles, and policies. Okay. And it's also going to pass information about what's happening on the cluster back to the Rancher server. Okay. Statistics, everything's listed here. Health information about the cluster, so that Rancher can make a determination of whether something needs to be changed. Okay. So that's one way in which you can work on the multiple clusters is through using Rancher. But of course, your cloud providers, they want to get all your business, and it's to their advantage to have something like that, like Rancher, built into their own platform. Okay, so that, for example, you can go to Google, right, and if you have to incorporate other clusters, you can manage them from the Google dashboards, right? So this is what Anthos is about, Google Anthos. So you can create clusters in the Google Kubernetes engine. You can also create on-premises clusters using Google Anthos. Okay. So this is the part of the Google service that also allows you to convert your workloads, your VM workloads, to containers. Okay, there's a tool for doing that, okay, to help you ease your migration into Kubernetes. It also allows you to, in this case, run the same engine that you would run in the Google Cloud, the Google Kubernetes engine. That same software can be run on premises. Okay, so if there's a reason why, for security or isolation or for some reason you want to run that, you can run it on your local hardware. In addition to running the same exact Google Kubernetes engine in the cloud. So what this gives you is the ability to not have different setups or configurations in those two different places, okay? Because you're using basically the same software in both places. Okay. Also, Google Anthos works with a Git repo for its YAML files. Okay, so there's something called GitOps, which is the name for using a Git repository for your configuration files, right? And there's a whole process behind doing that, so that you can version the files, you can roll back to previous versions, and it makes that whole process easier. So what's the architecture of this? So the architecture of this is a little bit different, okay, than what you saw with Rancher. So you still have an agent on the cluster, okay? But what it does is that agent on the cluster talks to the Anthos hub, So it doesn't work the other way around. So what the hub is responsible for is sort of publishing the configuration information that you set up. You're setting it up in a central location, and you're basically saying, this is how I want that cluster to be configured. So that information is available there, and then when the Anthos agent on that cluster calls into the hub, it says, let me look at the information. Let me look at how I'm supposed to be set up. Okay, so it pulls that configuration information from there. Okay, and then changes are made locally on the cluster to make it match the configuration that is in the hub. Okay, so what this nicely does is to safeguard the individual clusters. Okay, so you don't have one system that's in control of all the clusters in terms of having login capabilities, having abilities to push things out to these clusters. It's basically, here's the information, and then the cluster and its agent does, what it wants with that information. Okay, which is usually configure itself to that. Okay, but could also, not configure itself to that, in certain situations. So, so that's kind of an interesting thing about that architecture. Okay, and so that's everything that's there. And then there's EKS Anywhere. Okay, so this one, the focus in this one's a little bit different. It's not so much focused on connecting to anything, but what they mean by anywhere is your on-premises equipment. Okay, so that's what they're trying to get you. They're saying, okay, if you've got, if you don't want to get onto EKS because you have a lot of stuff locally, we'll make that easier for you, right? So we'll just let you manage that stuff, okay, from our management interface, and then eventually you can migrate it over if you want to. Okay. So in this case, the EKS console lets you view all the clusters that are running in these different locations. Okay. One thing about it is that if it will let you look at clusters that are on other cloud providers, but it doesn't let you manage them. Okay, so it hasn't gotten to that yet. If you want to manage your local clusters, you can do that. Your on-premises clusters, and if you have some nodes on some of your clusters that are ARM nodes, those are not supported. Right? It doesn't manage those, at least yet. Okay. Now, they also offer their own Kubernetes distribution. Okay, so it's a customized version of Kubernetes that's used in the Amazon EKS service. Okay, you can also use that for your local or on-premises Kubernetes installations. Okay, so so that's an advantage if you just want to reduce the amount of extra work that you do by having to know two different setups. Okay. And then there's in AWS, you're able to install certain components into your Kubernetes, add-ons. Those same add-ons will work if you use that same distribution locally, right? So you don't have to have, one networking add-on locally and a different type of networking add-on in the cloud, even though they're doing pretty much the same job. Okay. So I thought this was kind of an interesting table to talk about here. Though it got messed up a little bit when it got published here. But what you have here is this column is EKS, and the column over here to the right is EKS Anywhere. And this shows the difference between those two. Okay, so the Kubernetes control plane for EKS is, let's see, it looks like it's backwards. Oh yeah, so this one's EKS Anywhere, and the right one is EKS. So for EKS Anywhere, you manage the control plane. It's managed by the customer, okay, because you can run that locally if you want. On EKS, it's managed by AWS in the cloud. Okay. The location of the control plane, okay, again, it can be local in your data center if you're using EKS Anywhere. Okay, so if that's the need that you have. Or if you want to run it in the cloud, you use EKS instead. Then when you're upgrading your cluster, they can be managed by AWS, okay, or you can do it on your own locally, right? And then there's some more information about that here. If it's interesting to you to, if you're using both of these or EKS and using local clusters, you may find this, an interesting option. So more information like this, there's a lot more than just this part of the table. If you're in this situation, you can click on or, highlight the link here and go to that. Okay. Okay. So we've gone through a lot of information already. This last part was about multiple cluster management. Okay. So if it's a reality that your organization is working with multiple clusters, you may want to look at something like Rancher or one of the related multi-cluster management interfaces in the cloud service that you're using in order to unify your management of the different clusters. Okay, if that's something that you need to do. Most organizations are moving in the direction of having more clusters. Okay, so just unifying the management of it becomes something that is important and can save time and complexity. So, and that leaves us with just these two pieces here: Kubernetes skill sets and certifications, which we'll go through. I'd like to take a little bit of a break, just for my voice and to grab something to drink. If you guys want to get up and stretch, we're in the home stretch, so that's good. It shouldn't take long for us to finish out these two sections and then see if you have any questions. Okay, so I'm going to I'm going to go on mute for a couple of minutes, so probably about 5 minutes, and then I'll be right back. So let me put up a little note here. Where is Notepad? Oh, there it is. 1 second. Okay, there we go. Okay, be back in 4 actually. So see you at 2:03, and we'll continue with those last 2 sections. There we go. Okay, so that brings us to our last 2 topics, which would be skill sets and certifications. So Kubernetes is really expanding, in the marketplace and in usage around, organizations. So the projection is that there's going to be more and more need for Kubernetes professionals that interact with it in one way or another. Okay. So, so that bodes well for all of us who are, getting skilled up in it. But it also means that it's going to branch out into different types of roles, some of which may be more interesting to you than others. And you'll have a chance over the next couple of years to kind of get yourself into whatever niche in Kubernetes is that you would like to do your work in, and stay away from ones you're not interested in. Um, but it'll be harder and harder to be a generalist, meaning that you know everything about everything that's going on with Kubernetes, just because there's so much happening with it at the moment. Okay, so we'll go through this. We're going to start off by looking at related skills. Just, what are the skills that you need to have just to pick up Kubernetes to really, flourish and and get into the different roles that you need that are Kubernetes based. Okay. Then we'll take a look at some specific skill sets. This is more organized by role. Okay, so we'll talk about the skills required for different roles. So prerequisite skills. Okay, so if you're already in Kubernetes and you've been working with it, or it's part of your daily work, then you'll know that these are things that are involved. If you're looking to get into Kubernetes, you might want to take a look at some of these and make sure that you have some background in them. It'll help you move faster once you start picking up Kubernetes features and trying to understand what's going on with it. Okay? One of the things that's important as a prerequisite skill is skill with Linux. Okay, so that's with the operating system and the terminal commands. So, and there's only a handful of these things that you really need, right? You can get by with knowing how to open up a terminal and having like half a dozen to a dozen commands that you do, from simple things like how do I create a directory, to how do I check the network status and things like that. And if you know those things, then you should be able to do what you need with Linux, installing Docker, installing Kubernetes, running them, and things like that. The next part would be an application deployment. Okay, so if you're a developer or you're going to be a Kubernetes administrator, you'll need to do things like set up the environment. Okay, so the environment could be just the environment settings, like an environment variable, or something like that, or a configuration file. How do you set those things up for specific applications? Okay, you're going to have to know how to install your platforms. Okay, the ones that your application requires. So if your application requires Java, you should know something about that, setting that up, how that works. If your applications that you plan to work with are running in Node, you need to know how to install Node and set up and work with Node. Okay, and the same thing for any of the other platforms that you might be interested in. Okay, for example, if you want to work with Kubernetes, you need to know how to set up and work with Docker, right? For application deployment, you also typically need to know something about networking. Okay, how do you connect to your application once it's running? Because most of the applications we're really talking about here are networked applications. We're not really talking about standalone applications. Like way back in the day, you might have applications that were native applications, and then they would have a small networking component that would go grab some data from a database, something like that. Here we're talking about applications that live in a networked environment. They talk to each other over networking. They need to be configured a backend needs to be able to configure to talk to a database. It needs to know what to do when the database is not running. These networked applications typically have to have some kind of capability within themselves to register what the health of the application is. So if your application comes up and it can't talk to its data sources, it can say that it's unhealthy. It's not in a healthy state, right? So there's things about networking and application deployment that you need to know. Docker is what Kubernetes is based on. Okay. Now, some of you who've been working with this for a few years know that Docker is really like the birthplace of containers and containerization. But it's not the only game in town now. Docker is really being pulled apart, and they're taking different pieces of it. And you can have, for example, use Docker to create your images, but then to run those images, you could use a different container runtime, right? So you need to know something about how how Docker works by itself, and two, how things work when you're using something that plugs in as part of what Docker used to take care of, right? You need to be able to create images. You need to be able to stop and start containers. Okay. You need to be able to shell into a container so you can check around inside of that container and see if everything is set up the way it needs to be set up. And you'll need to know all these things even if you're using the containers inside of a Kubernetes cluster. Virtual machines, though at some point they start to seem a little bit antiquated because we're excited about using containers, which are lightweight, easy to start, easy to stop, and things like that. Remember, virtual machines, even though they were used to run applications, you can run the whole platform underneath the virtual machine. So you can have a cluster where the control plane node is a virtual machine, right? So you have a virtual machine that's that node. You can have other virtual machines that stand for other nodes. So it's not that virtual machines are going to go away. It's just that the role that they play may be different than in the recent past when they were used as a container for an application, right? Now they may be a container for a cluster, right? So you'll need to know about virtual machines, creating them, starting them, stopping them. Okay. So these are just some of the prerequisite skills, and I'm sure you could make this list longer by being more detailed, but I think you get the flavor of it. If you've been working in IT for a couple of years, then you've started to pick up some of these, even if you were never taught on them, right? But they will be useful and in some cases required to understand what's happening with Kubernetes. Okay. So we're going to take a look at a couple of skill sets or roles when it comes to Kubernetes. And the first one is going to be the administrator, then security specialist, okay, and then an application developer that loads their applications on Kubernetes clusters. Okay, so for an administrator, for that role, let's do this in the opposite order from what you see here. Let's go down to tasks. What does an administrator do, right? Provisions clusters, okay? So the administrator has to bring up new clusters when they're needed, okay? Has to set that up, set up the control plane of the cluster, okay, so that it's working properly. If that needs to be in high availability mode, they need to do it like that, okay? Or they need to know how to create a cluster on a cloud service if you're going to be running it in the cloud, okay? They need to monitor the health of the cluster. Are any applications having problems scheduling nodes because there isn't enough memory or there isn't enough disk space, right? So you need to check things like that. Keep an eye on the the throughput of the applications. Are the applications, are there some applications that really are barely running at all, but using up resources when they don't need them? Or are there ones that are dying to get more resources but can't? Right? The administrator has to be on top of that. So they don't just start a new application and that's it, right? That's when their work starts, is when the application is running. Okay, then they have to keep track of the health and the performance. Also, the administrator performs the cluster maintenance, which means upgrading the versions of the different pieces of Kubernetes when they need to. If there's a new security fix in a new version, then they really need to upgrade to that version to avoid any problems with security issues, right? They need to know how to upgrade applications to new versions when the developers bring them a new version of that application. They need to know the best way to upgrade it. Now, remember, we're running in a cluster, so it's not as simple as just stopping one executable and starting a new one. Okay, you've got to do that in multiple pods in order to get the application up and running. And what are the implications of running? You've got 5 nodes and 3 of them are running version 2, and as you're upgrading, 2 of them are running version 3. Right? What are the implications of that? Is that a problem? Is that not a problem? And factoring that into your cluster maintenance. Okay. So these are some of the tasks that the administrator takes on every day, so that their skill sets need to reflect the skills needed to do those things. Okay. So with that said, we'll go to the skill set here and see that so they need to be able to create and scale the clusters themselves. So let's see, deploy and scale applications. Okay, so the first one is about the cluster and the cluster's resources that it has that can be applied to applications. The second bullet is about deploying the applications and using those resources. So setting things up for that, they need to have that skill set. Then once things are running, they need to have the skill set to set up monitoring of the clusters and of the applications, and then if possible, set up alerts, useful alerts, okay, that will tip them off to when there are problematic situations, and then need to know what to do when those alerts come in. Okay, so those skill sets. And then that part of that is maintaining the clusters and applications at the proper version levels, so that they're not using a version that's too cutting edge of something, but not using an old version that has security issues or things of that nature. Okay, so that's kind of the role of the administrator, right? So one of the things you can do as we go through these different roles is to just say, well, yeah, that sounds like me. That's what I'm doing, or that's where I'd like to be. I'd like to be somebody involved in that aspect of Kubernetes, working as an administrator. Or you might fit into one of these other roles that we'll be talking about. Okay, the Kubernetes security specialist. Okay, so again, we'll go through the tasks and then go through the skill sets. Okay, so the security specialist doesn't necessarily start Kubernetes clusters, right? But they design security implementations. Okay, so they look at this situation, knowing how Kubernetes is set up, knowing how the applications are set up, and look at it to understand the security profile. What is there that could be problematic? From everything from how does somebody log in? Can somebody log in who's not allowed to log in? Can somebody who's logged in access services that they shouldn't be allowed to access? From something as basic as that to what happens if somebody gets access to the the node or the machine that something's running on, is there any way that they could, possibly get access to data that's sensitive data, right? Can somebody modify one of the images that's being run and cause problems in that way? So they have to look at everything about how these things are run and know the architecture completely so they can design the security implementations. What are they going to do that is going to be, and they're going to work with the administrator to set those things up on the clusters. Okay, so they decide how the API will be secured. Okay, remember the Kubernetes API or the API server is what you talk to, or what all the methods of modifying the cluster talk to in order to get something done. Okay, so you talk to the Kubernetes API server and tell it, I want to bring up this application. Okay, the API server then notifies whatever it needs to notify within the cluster so that can happen. And when you're using the kube control, a command line interface, it talks to the Kubernetes security, Kubernetes admin API. Okay, the dashboards also talk through the API. Any other tool, like if you have an agent, a rancher agent, they're going to have to talk through the API. Okay, so what this means is that this is a good place to secure things. So the security specialist is going to need to know how to secure it and how to set up who's allowed to do what. Okay, can they even access the API? If they access the API, are they allowed to do this or that? Right, so they need to understand how to set that up. Okay, so overall, and the last one's kind of a combination of the first two, sets the direction on how Kubernetes applications will be secured. Okay, I guess another thing the security specialist might do is be brought in to audit a specific installation in a similar way to how security specialists are asked to look at applications and check for vulnerabilities before they're put into production. So they might say something, oh, you're using this interface, so that interface is, we know that interface is buggy, you shouldn't use that. Or we know that this way of authenticating has been deprecated, you shouldn't be using that. Okay? So the security specialist may also be brought in to do that kind of audit on a cluster. Okay? So what do they need to know in order to do these things? So they need to know network security in general, even as it exists outside of Kubernetes. They need to know security for networked applications. How do you secure a network application, whether it's Kubernetes or not? Okay? They need to know security for the Kubernetes API. How can you secure that particular service? Okay? And then they need to know Kubernetes networking, how applications are set up via a network service to be accessed, okay, so that they can make sure that those are secured as well. Okay? So those are some of the things that come into play with being the security specialist. Again, this may be something that looks good. You may be somebody who has a real feel for security and want to move in that direction. And one of the other things that you might do, or you might have an affinity for, would be creating applications. So maybe you're an application developer, and you like the fact that Kubernetes will let you really scale your applications so that they can be used by more and more people, and that it can let you set up an application to be fault tolerant, so it can be used 24 hours a day without any downtime. It lets you update the application while the old version is still running. So there's a lot of things that Kubernetes does for an application developer for their application that that may make you want to become somebody who straddles both worlds as a Kubernetes professional as well as a developer. Okay? So the developer develops applications, tests applications, packages applications, deploys applications. Those things you already know. The skill sets you'll need for that start off with application development, right? So you really need to already have that in your back pocket. That I'm a Java developer, I'm a Node developer, whatever developer you are. You need to have that there first. Then on top of that, you can start adding the understanding of clustering of applications using Kubernetes. Okay? Before Kubernetes came out, there were clustered applications. They just, they would write the clustering as part of their own application. As hard as that can be to believe, there's so much involved with Kubernetes. It's nice that somebody else wrote that, right? That you don't have to write that as part of your project, right? You have to integrate with it, right? But you don't have to write the clustering part. But that used to be part of the application development process, right? And then you need to know how to deploy applications to Kubernetes, and not just this simple deployment, but actually, deploy it and say, how much resources do I need to assign to this? You have to have an understanding of testing in the environment of Kubernetes, okay, so that you can set up the quotas that you're going to use when the application is deployed. Okay, how much disk space should you assign to one instance? What's the maximum disk space that's really practical for your application before you really want to have a second instance instead, right? Does it make sense, that you can use up, 20 gigs of disk space or 5 gigs of memory? Can you really utilize that well, or is it better to have a smaller amount and then just more instances, right? So you have to answer that question. You have to understand what's involved with answering that. Okay, so that's some of the things that you would need to know as a developer in order to really work well with Kubernetes. Okay. Now, this last category is Kubernetes-related professionals. Okay, and there's a lot of people who fall into this. Okay, whereas that you don't want to be an administrator. You don't want to sit there every day and administrate clusters. You're not a developer, and you've never really gone in that direction. It's not an interest of yours. Okay, but you are involved in application development, right? You might be a tester. You might be an analyst that helps, helps define the requirements for applications. Works with the end users to figure out what they want. You might be a manager, okay, that manages a team of developers, okay, or or a team leader. So any of these others that don't fit into the Kubernetes admin or application developer role may still need or will profit from knowing more about Kubernetes. Okay, and part of this is so that they can interface or talk to the developers in an intelligent way about the application, and talk to the ones who put up the application and who monitor it. The Kubernetes admins. These professionals, the related professionals, need to be able to talk to them with an understanding of what they're dealing with, right? You can't just say, oh yeah, just put up the application and be done with it. You have to understand it's going to involve this and this, and there may be reasons why you need to gather more information for them. Especially if you want the application to be successful, or if you want to find out why the people on the West Coast are complaining about the application, but the people on the East Coast are fine with it. Like there's reasons for that. That you might have to somehow react to. Okay, so there's a lot of different roles, and I can't list all of them here because there's new roles every day in these different areas, but I'm thinking mostly in the application development area, different roles where you would benefit from knowing more about Kubernetes. Okay, and that leads us to the final thing I wanted to talk about today, which was certification, and not just CKA certification as it's listed here, but basically Kubernetes certification. Getting certified so people can know that you have a certain background and understanding, so that they can plug you into certain roles and know that everything's going to be okay. Right? That's really what certification's about. Okay. So we're going to start off with what I'll call the call to action. You'll understand that once we've gone through it. Then we're going to talk about the organization that does the certifications, that puts out the exams, and then talk about the 4 certifications that you could get currently in working with Kubernetes. Okay. So the call to action. So this is what we know already. Kubernetes usage is expanding rapidly. There's more and more articles about it. There's more and more people downloading it. There's more and more companies using it and using more of it. In addition to that, there are related technologies that are emerging very quickly. Okay, because as people use something more, they also see, oh, this could be easier if it had X, right? And then some of those folks will go out and create that piece. Helm is an example of that. They were saying, wow, Kubernetes is great, but you know what? If I want to load stuff up and make it easier for other people to load it up, we'll make these Helm charts, and that will be, the way that you create applications or you load applications. Okay, so these related technologies are emerging quickly, which means that the whole system within which Kubernetes works is expanding. Okay, so it would be good for anybody who wants to continue working in this area to complete their basic certification as soon as they can. Okay, as a preparation, okay, for these other things that are going to be coming up. Okay, these other things, and some of which we talked about today, right? So, for example, multi-cluster management. Okay, in order to be effective in managing multiple Kubernetes clusters with a multi-cluster management system, you need to know Kubernetes. Okay, and then on top of that, you need to know how those management systems work. Okay, so you need both. Each cloud provider, which hosts their own Kubernetes in the cloud clusters, okay, has been adding variations to Kubernetes and enhancements like different types of auto scaling. It's just one example, right? So they're adding all these capabilities, service meshes and networking and things like that. So you need to know Kubernetes to start off with, and then on top of that, these other features, okay, are coming out, which you'll need to know, these variations and enhancements. Okay? When it comes to creating applications, so you can create an application now and load it up in Kubernetes, but there's also the possibility of stitching your application into Kubernetes in more effective ways. So not just allowing standard types of logging, standard types of monitoring and things like that. You might want to have a monitoring feedback loop within your own application, right? And you can do this by using certain of the Kubernetes technologies to write your own add-in that's only useful for your application, okay? But that lets your application read information about how it's working and adjust itself, right? So then what happens is you have an application that's built to work specifically on Kubernetes because this capability to write a plugin that helps your application is available, right? So that's something where you need to know Kubernetes, you need to know application development, plus then you can write an add-on that really makes your application shine. Okay. Edge computing, where you're trying to run the application in data centers as close to the end user as possible, right? So again, you need to know Kubernetes, plus you need to know about the cloud services, how to set up things in different regions. Okay, so you're seeing these things add on top of Kubernetes, and so it really, it makes you um, it's exciting, it's interesting, but you got to do one thing before the other, one foot before the other. So you have to really nail down your Kubernetes understanding first, and then build on top of it. And one of the places that's going to help you do this, one of the organizations, is called the Cloud Native Computing Foundation. Okay? It's a part of the Linux Foundation, and this is the place that offers exams that lead to the certifications in Kubernetes. Okay. Now they have a charter, or like a little manifesto, right, about themselves. Part of which says they want to make cloud native computing ubiquitous. Okay, which means that it's running everywhere all the time. It's just all over the place is what they want. And it kind of makes sense. It's a useful technology, so that can happen. Okay. Now, in addition to creating the exams and running the exams for the certifications, okay, they also run developer conferences. KubeCon, which is your Kubernetes conference, okay, Cloud Native Con, Cloud Native Security Con. There's like a dozen different developer conferences that they run. Okay, and in addition to that, they also offer these free online programs that come in the form of like webinars, free webinars. And there's other benefits. There's like a job board and things like that. So it's not a bad idea to spend half an hour on their site seeing what they have. The Cloud Native Computing Foundation. And here are the certifications that are important to individual professionals. There are other certifications that play in different areas of Kubernetes, like if you want to run a consulting shop of Kubernetes professionals, there's some kind of certification for that. There's a certification of Kubernetes itself, of if you want to create a distribution of Kubernetes, things like that. So those you can see on the site, but the ones that we'll talk about here are these professional certifications that you can use as an individual IT professional. Okay. First one's the Cloud Native Associate. That's the newest one. Okay. And we'll take a look through these. They'll each have their own page. The Kubernetes Application Developer, the Security Specialist, and the Administrator. So you see that these are matched with the previous chapter that we went through, where we were talking about skill sets and roles. Okay. Okay. Before we go into those specific exams, let's talk a little bit about the exams that this foundation puts out. Okay. So they're a little bit different than maybe other certification exams you might have taken in the past. The exams are typically performance-based as opposed to knowledge-based. Okay. What this means is that for each question, the candidate has to actually do something. There's going to be a live cluster that's brought up on your machine, and you have to run commands to make it do something. Install an application, deinstall an application, troubleshoot a problem in the current cluster. You have to do it on the live cluster. So those are the kinds of questions that you have. It's like, go do this, and then you go do that, right? So not so much multiple choice, for example. So the exam needs to take place in a room that's a quiet room where you don't have anything else going on. You can't do it in the lunchroom. You have to do it in a room that's dedicated to that purpose for the duration of the exam. And the exams are about 2 hours. One of the exams used to be 3 hours, but they kind of backed it off, and it's 2 hours now. So you need this quiet room, and one of the things that'll happen is you'll have a proctor, somebody who is going to be watching you the whole time over a video link. So you'll have to have a webcam, okay? And they will actually ask you to point the webcam around the room so they can take a look and make sure, like, for example, you don't have the big Kubernetes cheat sheet pasted in front of you, something like that. You will be able to use any of the documentation from the Kubernetes documentation site, which is a huge amount of documents. But if you don't know where you're going in there, it won't help you, right? Because you won't have enough time to find the information if you don't know where it is already, right? So there'll be a proctor, and they ensure the integrity of the exam, that you are not cheating, and that you're not copying and pasting answers from somewhere, things like that, right? And then you'll finish the exam. They don't give you the results right away. The results will come about, maybe 24 hours later. You get an email telling you what the result is. Okay? You're allowed to retake the exam. Okay, I think when you buy an exam, that gives you 2 chances. You can take it once and then take it again if you fail, or if you want to just up your score. Okay, and so that, and then other than that, you'd have to buy another exam, right, if you wanted to take it again after that. Okay, so that's some of the details, but they really are good about posting all of the information about how the exam works, and what you need to do, what the environment is going to be like. That's all there. You can read all of that before you ever get involved with it. Okay, so that's on the CNCF site. So with that in mind, let's take a look at the Cloud Native Associate certification. Okay, that's the first one listed here. It's actually the newest certification. It came out this year. It's in addition to the other certifications that have been around for a couple of years. Cloud Native Associate, okay, is designed for people who need to understand the basics of Kubernetes, who might be working in a team that uses Kubernetes to do something. Okay, this kind of fits into that last category of Kubernetes-related, professionals, where you're not an application developer, so you're not going to be taking that certification. You're not an administrator, so you're not taking that one. So you take this, to show that you understand everything that you need to know to work with other people who are working with Kubernetes, right? So it provides a base. It also provides a base for you to get into those if you want to. So if you're working as a tester, and you need to know the Kubernetes platform in how it works with testing, so you do this certification, and then later on you say, oh wow, I'd really like to become a developer. So you retool on development, and then you might take the developer version of the certifications. Okay. So what's covered in this exam is basic understanding of Kubernetes, okay, plus basic understanding of other cloud-native technologies. Okay, so it's not just I know what a cluster is, but you also know about the other services that different cloud providers have. So they have services that are related to networking. They have services that are related to data volumes that you can put data on, things like that. They have software as a service and things. So you need to know something about how those work as well. Then specifically about Kubernetes. You need to know how to deploy apps using kube control. So you don't need to know a lot, but you do need to know that much. You need to know the Kubernetes architecture. Okay, you've got the API, you've got the data store, you've got the nodes, you've got the pods. You need to know that. And you need to know something about these other areas: cloud storage, networking, GitOps, service mesh security. So these are all the things wrapped around Kubernetes. Okay, so those are what the exam covers. But you should know that this is not a stepping stone in terms of you don't need this to take the admin certification. You don't need to have done this to take the developer certifications. Those can be taken whenever you feel like you're ready, right? So this is something that you take because you want to learn that much, and you want to be able to demonstrate that you know that much for whatever role you're currently in, right? And then if your role shifts and you're in a different role, you can take whatever other certification works for that role. Okay, then there's the certified application developer for Kubernetes. Okay, so this one is pretty straightforward. It's for application developers whose applications are meant to be run under Kubernetes. Okay, so they need to be able to design and build, configure, and expose, which means to set them up to be networked and accessed. So their applications, they need to be able to do those things for them in the context of Kubernetes, right? So it covers this application of cloud native concepts. So they know about volumes and they use them. They know about networking, they use it, that kind of thing. Working with container images, so creating images or creating images on top of other images. How to deploy and scale applications, their own applications. Application logging and monitoring, how that works in Kubernetes. Okay. And then Kubernetes services, which is the way that you set up the network in Kubernetes so that somebody can access your application, and the way networking works in general inside the cluster, and how you can have an ingress to access it from outside the cluster. Okay. So, and again, this is going to be a practical exam where you're going to have to demonstrate these things. So it'll say something like, there's an application running, set up this application so that you can access it from this IP address or something like that. And then you'll do whatever commands you need to do in order to do that. Okay. And I think this is the last one we look at. Certified security specialist. Okay. So this is for security professionals who want to be involved with securing Kubernetes clusters. They need to know about the setup of a cluster, because some security measures are implemented at that point. Okay, so hardening the cluster. Okay, that means making sure that people can't easily access the cluster without, having the proper authorization. System hardening, so for the operating system, or for the virtual machine that something's running in, or the container that something's running in, whatever is being used to run the cluster, making sure that there isn't some way somebody can use that to attack the application. Minimizing vulnerabilities. There's a whole list of different types of vulnerabilities that are common. There's a whole organization that revolves around publishing those things and helping people figure that out. So the security specialist needs to be able to understand what those vulnerabilities are and how to apply measures to minimize them on a cluster. And they need to know about monitoring and logging in these applications, and runtime security. Okay. So that's what you would get into, and there's more details on this on that site that you can access. Okay, so you'll know what it is you need to know for the exam. And in addition, there are plenty of places that you can do sample exams ahead of time. The platforms might not be exactly the same, but they're similar enough so that you can get an experience that's similar to what the test is going to be like. So you can feel what it's like to do that kind of work under a situation where there's a time limit, okay, and there's a specific thing that you need to do, and you need to do that to help test your own understanding. Okay. Oh, yeah, and the most obvious one, which I almost forgot, which is the Certified Kubernetes Administrator. Okay. So this is for people who want to be or who already are Kubernetes administrators and just want to make sure that they fill out all the different understanding the different topics that are involved with this, even if they haven't had to deal with them yet themselves. Just by preparing for the exam will help kind of fill in those gaps in whatever knowledge that they have. Okay. So this test covers cluster architecture, installing clusters from scratch, configuring clusters. Okay, so setting up, what they have access to, where the control plane runs, how the control plane is set up, whether it's multi-node or not. Okay. Then, of course, they need to know how to work with workloads and schedule workloads onto pods. They need to know how to set up services so that people can access the applications that are running on the cluster. So services and networking are tightly related, so they'll need to know networking as well. Need to know how to allocate storage, set quotas on storage, things of that nature, and how to troubleshoot common problems with a cluster. So if you see, for example, you try to start an application and the application doesn't start, right? What's the problem there? You try to scale an application and you can't scale the application. It won't do it. What's the problem there? If the application is cut off from the control plane, what happens? What do you do? So you need to know how to troubleshoot the application and then set it right. Okay? And again, all in the context of an exam where you're doing these things on a live cluster. Okay. So that's all the content that we were going to cover today. Again, we talked about these different things. Cloud managed Kubernetes. Okay. So are you running your clusters in the cloud? You're running some of them in the cloud. Who are the providers, and what and are there anything specific about the way they provide things that's different than other providers? Okay. Application and package management, who's really talking a lot about Helm, which makes it easy to load up applications and then set up your own charts in order to load applications, unload applications, upgrade the versions, and things like that. Multiple cluster management, what are the options for managing multiple clusters from one interface, right? And Rancher is one of the main ones that we saw there. Okay. And then we talked about skill sets and roles. What are the roles that you're involved with when working with Kubernetes? What skills are involved with those roles? And then we talked about the certifications kind of that match those skill sets. So, and just talked about a little bit about the fact that, why get a certification if you're already doing something? Well, you get a certification in many cases so that you know that your background is equivalent at least to others who are doing the same job. Okay, you get it because you want to get a job. Maybe you're applying for a job and they want to be able to know, like your manager knows, and the people who work with you know that you know what you're talking about. But how does somebody who's hiring you know? Well, certifications is one of those ways. And another reason to get the certification is so that you have that background that you can build on. Okay, so you don't have holes in your knowledge, and you can build on that as these new things come out in the Kubernetes kind of ecosystem, and you want to take advantage of those. You already know the basics so that you can build on it. Okay. So just wanted to say, make a note about us. I'm from WebAge Solutions. We're a training company. And we offer all kinds of customized training, standardized training. Here's a couple of items that we offer. But there's more. So if you have a team of people you need to be trained, certainly you can contact us, and we can work up a proposal that takes care of whatever your needs are. So I want to thank everybody for coming to the presentation today, and for sticking around, as I know that 3 hours is a long time to dedicate to anything when you've got a lot of work to do. So we appreciate that.